Okay, should be good to go, but let me make sure we are actually good to go. Oh, there we go, sweet. Nice. Okay, let me. There we go. Okay, yep, and audio is fine. Okay, let me. I want to hide the view so I don't have to like stare at it. Can I just minimize this? There we go. I can just minimize it a little bit. Okay, great. Okay, rust time. Okay, let's see. First thing I do is see what we need to do next. That's going to be somewhere in handle peer. Oh, actually, we are. Yeah, we're at the point where we can start the request piece message loop thing. This actually might be where we really should go to um, back to engine or back to our engine and start working on this again or refactoring this. Um, okay, because okay, so like some of this is okay, some of this is not. Okay, so like okay, this is gonna be gone. Like this is gonna be gone, um, but not everything. Okay, let me just look. So this general idea is still fine. This is just gonna be changed to peer.handle peer, and then we're also gonna have to save and store some stuff. Let me see if there's any more tests that I could write before I do this because I haven't probably have not tested enough. There's also a bunch of irrelevant code that could really be avoided because it's just not necessary. Um, well, actually, no, it's not necessary. It's literally I'm going to delete it once I'm done with it, which will hopefully be soon. Because this is a test peer connection, and then let's see. Let me just there. Access their test peer connection. I don't think we really need to test anything else because we know that that's a good peer and we know that that peer works. Like if I check out hold on, general projects tortillas, I do cargo, next test run, no capture, what is this? Test peer connection. Test peer connection. I'll double check this again, but I'm pretty sure it's working fine. Let's see. Loading. Oh, well, see. Okay, I'm kind of glad that I tested that now. Um, oh, actually, that peer might just be dead by now. Okay, that kind of makes sense. Anyways, that did work at one point. I'm just gonna act like it was working. Okay, so this is generally what we want to be doing. So, okay, I guess now we do kind of want to do the engine because I don't know, like, well, actually, no. Hold on. We can still do this. We just can't really test it. Because, well, no, we can. We can. Uh, we're gonna have to think about how we want to design this though, because okay, so see, the idea, the idea with this, right, is it's gonna be something like this. Is that, or is that everything here is gonna look something like this? So the from tx from rx is gonna be messages from the engine, and then the to tx is gonna be used to send messages to the engine. So ideally, what we should do is basically just do a while let, but that doesn't. I don't think that's right entirely. So, um, from rx dot, you gotta wait, but again, I don't think this is. I don't think this is entirely right. At least I don't agree with it entirely. Oh, it should be some, not the result. Some message. It seems to be declared as mutable, obviously. I don't know. Actually, I guess I just didn't do that because it would yield anymore. Okay, yeah, so let's do this. I need the message. Okay, so ideally, I think we're still using transport command here, which is fine. Actually, I'd say that, what are we using here? Yes, transport command. So transport messages. Yes, we're using a transport command. We're gonna have to refactor that a little bit. And it's probably gonna be better to call that like. Actually, we probably should just make that like peer command or something, because otherwise it's gonna get so confusing. Okay, so should we probably should have a peer command enum. So let's go here. Let's do command rs. That should be fine, hopefully. And then I should need to go to mod.rs and pub mod that. So pub mod command.rs mod command. Let's do commands. Let's rename this to commands. This is gonna be deleted. It's fine. Go back over here. You're gonna be fine. Why is it mad about that? Commands that rs cannot find. Huh? Okay, we're gonna act like that's not happening right now because I don't know why that is happening. Yeah, we're in peers, and that's peers./modrs. Let me just. I was gonna act like it's not happening, but I want to actually figure out why that is happening. Let's see. Oh, okay. It might just fix itself after I change that. Okay, whatever. Anyways, this should be a pub enum peer command. Let's have. Okay, so ideally, what we're gonna do. Okay, you know what? We're gonna take this to the whiteboard. We're gonna be fancy about this. Ideally, what we should have is the engine, which then communicates to each peer. And these are our peers. The engine should be able to say, well, okay. The algorithm that we use for this is going to be interesting, I guess, because I'm not sure how to go about this, because, well, hold on. Let me look at my peer messages diagram. So the only thing that involves the pieces is the bit field, and then the piece, obviously, which we're going to have to return to the peer. Oh, I didn't do that. What the hell? Which we're going to have to return to the engine, which is not that hard to do, which is fine. But, okay, so the bit field, see, this is what I don't know, because the bit field, I don't think that the engine inherently needs to know what bit field each peer has, because I think, okay, so let's say this peer has, here, let's just do O for does not have, and let's do binary. O for doesn't have, and 1 if it does have the piece. So let's say that peer is like that, and then this peer is like this, and then let's say this peer is like that. What I'm thinking about doing is basically just have the torrent engine go through every peer, or not every peer, but more specifically every peer's not transceiver, sender channel, and just saying, hey, go and ask for piece 1, and then saying, hey, ask for piece 2 from this peer, then ask for piece 3 from this peer, and this peer will say, hold on, okay, we do actually have that, so we'll return and say yes. But the other two peers are going to say, no, we don't have that. But it doesn't. I don't know if that's going to work though, because let me see. Okay, so we get. Okay, but well, I mean that could work in theory. It's just gonna be a weird design. Yeah, that's gonna be really weird. I'm not really sure, to be frank with you. So, okay, let's go back over here to your mod.rs. Let's see. So, okay, if we have the bit field, well, maybe. Huh. Yeah, I just don't know how this. algorithm should go. Okay, is there a pre-existing algorithm for this? I can look at the BEPS just to start. Okay, for obvious reasons, there's no forced way that pieces have to, or for forced order that pieces have to arrive in. There's a white paper, could be useful. Is this the same thing? This is not the same thing. Is this? Wait. This is not the same. Wait. No? I don't even know what this is. I'm gonna be honest, I have no clue what this is because I've never heard of any of these terms. Okay, we're gonna ignore that for now. BitTorrent. What order to select pieces, and let's see if there's anything like pre-existing. Connect users. So I guess the rarest piece. I mean, that kind of makes sense, but still, like, it's rarest first, however, sequentially or supersede. It's rarest. Okay, that makes no sense. It's mostly random, but speeds get high enough, will start down like sequentially. So I guess my thought is then how do we do that? So it's either rarest first, which could definitely be potential. It would involve us sending the bit field back to the original peer, not peer, to the engine. But that's still, I mean, that's doable. So I guess yeah, I don't know, because then now we're having to keep track of like state and stuff, and that gets nasty quickly. Maybe if we, how do we? I don't know. It's like this idea is the engine has no idea what bit fields the pieces have, but that's not really. I feel like that's not really that viable, you know. Well, I mean, okay, no, I say that it could be viable. It could definitely be viable. Because I mean, think about it this way. Maybe we just okay instead of trying to do this asynchronously, maybe we do it. Oh, where's my eraser? Um, a little bit more sequentially. So we basically go to okay. So let's think about this not in a whatchamacallit, remote way, but just locally speaking. What if we go to every thread that the peer's on, and we say, okay, hey, do you have piece one? And the peer writes back and says, no, I do not have piece one. So no request is made, no nothing. But then, yes, okay, see that, okay, so that's the thing. I feel like we do need to send the bit field back to the engine, because otherwise what we're going to have is basically a bunch of, we're going to end up asking for the bit field, asking about every single piece of the bit field for each peer, because we're gonna go, okay, peer one, do you have piece one? Do you have piece two, piece three? And then peer two, do you have piece one, piece two, piece three? That's not gonna be great. So what we instead could do is initially send everything back. So do something like this. I don't want to erase that because it took so long to draw, but maybe I'll just move it a little bit. We're going to move everything back. And then what we're going to do is we're going to say here, the hash obviously would look a lot different in code, but we do something like this. This would be 1, this would be 2, this would be 3, And then ideally what you would do would be, okay, so once peer 1 has a bit field, it sends it back to the engine, which is that basically. It's a horrible arrow. Okay, when we do the same for peer 2, and then we do the same for peer 3, right? And now the engine has the bit fields of all the peers. And now ideally what we can do is we should be able to find some way to go through. Oh my God, I'm so smart. Okay, I was kind of leaning towards a hash map, kind of for obvious reasons. But what we can do, we can have a hash map, and what we can do, we can have a table like this. We can do something like this, and then what we can do is we have, so this is pieces, by the way, not peers. So pieces, and then peers plural. Okay, so for piece one, only peer 2 has it. For piece, I'll put a little like number there. So for piece number 2, only peer 1 has it. For piece number 3, only peer peer 3 has it actually. Only peer 3. But then, like, imagine if one had other pieces. So if one had pieces like one, if they all the pieces, then 1 would be added to this. And while I might not do this initially because it would be kind of complicated, we could just make that request to every single peer, and just see who returns the piece the fastest, right? And then use that, and then ignore the piece request from the other peer, which honestly would not be that hard to implement, would be totally doable. It would just be something for the future, you know? But anyways, okay, that would be not stupid, I think. Because now, because see, now the engine knows, okay, peer 1, I know that you have piece 1, so I'm going to go ahead and ask you piece 1 with full knowledge that unless something goes wrong on transmit or the peer sent an incorrect bit field, you're going to give me that piece back. And then we could do peer 2, same thing. Peer 2, I know you have the piece that I want. We can do the same thing for peer 3, and then we can just wait and expect those pieces. Okay, that seems reasonable. So I guess the other thing is, what happens when we get to a point where we aren't confident about, well, no, so hold on, let me organize my thoughts. What happens when we get to a point that, okay, imagine this. So if peer 3 just never returns a piece. So, okay, so peer 1 and peer 2 all return the pieces that they should. So our final pieces look something like this. So we have these two, but we don't have this. How do we handle that? This is definitely a problem with the engine itself, but no, not a problem, but just something to deal with the engine itself, not the handle peer. But maybe you should think about it like that. If we don't have that, okay, so maybe what we need to do, so we need to have this hash map, obviously. We need to have a vector for the final pieces, which I don't know how we're going to store that. If we're just going to like write that to disk immediately or keep it in RAM. I'm not sure how that works. We'll figure it out though, I guess. I mean, there's no way you could write it to RAM because the moment a file's over like 4 gigs, that's kind of stupid. So I guess you just save it to disk. But anyways, then we also need a vector that kind of mimics this vector, kind of copies off it, but it's just a bit vec or just a bool vec, whatever you want to call it, of pieces that we do or don't have. And maybe every so often, like, but no, okay, I was gonna say every so often we go through and get all the pieces here, but that wouldn't really work, would it? Well, I guess if we have a timeout. Okay, okay. So maybe, well, once we know that like 3 has failed, right? So 3 returns because it either timed out or something went wrong with the transport. Uh, we include the piece message, or sorry, not the piece message, the piece number. We say, hey, we couldn't get the third piece from peer 3, so we need to request that piece again from someone else. We go back up to our hash app and say, okay, peer 3 didn't work, so let's remove that, but let's try and request that from somebody else. Okay, that seems reasonable. Okay, okay, I like this. I like this. So we need to return the bit field and then go from there. Okay, okay, you know what? This actually, I'm pretty happy with this. I'm really, truly quite content. So we need to 2tx.send. It wants a transport response, but really it shouldn't be a transport response. It should be probably a peer. What do you think? I don't know what we want because we're also here. Let me. I can open up transport messages because we're gonna copy off of this a little bit, maybe. Maybe question mark. I don't really know. Peer response, and then okay, so we have the init. We're gonna have to copy some of this over. Wait, no, this is the transport. So this is the peer response. We have init and import MPSC from Tokyo. Should be a peer command, which is already imported. Okay. We're gonna have to refactor a little bit of this, but that's okay. It's not that bad. So this should be a peer response. Oh boy. Peer response. And then this should also be a peer response. Oh hush, you're gonna be fine. Peer response. What is that about? I'm kind of confused. What? Line 152? Oh, that would do it. There we go. So tx.send. That should take a, yeah, there we go. Should take a peer response now. So it should be peer response, and we're gonna do basically this. So just that, and this should be peer messages, and then peer key, which is just a type basically. Receive, and the message should be the. Actually, we should probably just do that in here because there's no reason to do it anywhere else. The message should be peer messages. Actually, like from bytes, I think. From bytes self dot p. Oh my god, self dot pieces. Peer key is just equal to self dot socket adder. Should work. Let me see. Oh, what is it meant about? Oh my god. I could probably unwrap that. I see what it's unhappy about now. Oh my god. It's imploding, chat. Okay, that's fine. Actually, it's probably mad about that, isn't it? Yeah, okay, there we go. I was gonna say, oh my god. So it wants, okay, can I just change it to a U8? Or should I do, because bitfield is gonna be, that's not gonna convert it, right? Yeah, no. Okay, so self.pieces, I don't know how I could do this. I mean, I think that iter, because that's gonna create a dot iter. But this is gonna, oh, will that actually just work off the bat? Okay, yeah, no, of course it won't. I was gonna say, like, that would be magical. A value of type cannot be build over the chain not should be iter mute or whatever it is, not iter like whatever the fuck it is, I forget. Iter. Why is my shit just gone? Oh, because I'm recording maybe. Dot iter into iter dot collect. I forget what the difference is exactly, but I know it's something. Because you're removing this method call as the receiver has type standard vec bool. Okay. Oh yeah, that's I could just Google this, but I don't really want to. You know what? I'm just gonna Google it. U8 to vec rust. Wait. Oh, bool vec to U8 vec. I mean, mom texted me. Hold on. Sorry, chat. Okay, actually, no. It cannot be that hard. How is it that hard? Oh my god. Okay, I could probably just do like, give me a second. Oh my god. Okay, anyways. So into iter, can I do like a, not, what's it called in Rust? The thing where you do the two brackets, you take like a variable. It's like map in JavaScript. I'm just gonna look at vec functions. Vec functions Rust. Because I want to go, yeah, let me see. Not with capacity. How do I do something iter? Like I could construct it by hand, but like that would be kind of a waste. Wait, hold on. Self.pieces. No, because bitfield is not. Bitfield is a. Yeah, is a bitvec. Wait, can I just like convert? Yeah, okay, I can. I think I can just do into. Can I? Let me see. That would be nice. Oh. Okay, that makes sense. Dot await dot map error. I don't even know if I'm doing this right, but I'm hoping I am. Error sending bitfield back to error sending bitfield with what is that called? Error sending bitfield with peer, not peer messages, with 2tx on peer, peer on self.socket adder. There we go. Display the error too. That would be stupid if I just didn't do that, wouldn't it? Okay, then we can unwrap that and just let it implode, I think. We could actually handle that, but that's just silly, isn't it? Yeah, it's just silly. Okay, so that should be decent, and then so we send. Oh goddamn! My mom's vacuuming. Okay, hopefully that's not. Hopefully you can't hear that. Oh my god, so loud. Okay, we're just gonna ignore that. This is a lot, so send bitfield back. Likely to engine. Okay, I'm just gonna delete that for now because we're not really doing too much there yet. Okay, so we send the bitfield back. There's my nice little diagram. Let me slide this back over because I don't need it anymore. I hope you can't hear my mom in the background. This is so embarrassing. So, okay. Okay, so we send it back. We're obviously gonna have to do some stuff with the engine, but I think that's gonna come after we finish handle pier. Cause like really, like once we're here, this shouldn't be too bad. It should be reasonable to do at worst. Yeah. So I think, hold on, I should think if I can go, if I should or could go ahead and commit this. But otherwise, we're just gonna go ahead and start implementing that, which shouldn't be too bad to do. So, yeah, and then, yeah, because the engine is going to completely control what bit field we get sent. Yeah, so, or it's not, sorry, not what bit field, what piece the peer, what piece we ask the peer for, right? So we really just need to wait on something and then start making the request and waiting for the responses. Yeah. So, next question: should I go ahead and commit this? I feel like I should. Just for my own sanity. Oh, right. I also created commands to RS, so that would honestly, yeah, we probably should go ahead and commit this. Yeah. Okay, let me go commit this real quick. Get add, get commit minus m. Feet. Send bit field back to bit field back with, what was that, 2rx or 2tx, sorry. Okay, I'm going to push that, and then, okay, carry on. Okay. Oh yay, I can finally pay for college. Yay, time for debt. Okay, loop. This is where we're gonna start to really think about this. Actually, I don't think we really need to do a loop, do we? I think we just need to do a while let some, I guess, yeah, let's call this command is equal to, from rx dot receive dot await. Okay, so right now this should only be a, whatchamacallit, not, what do you call this? I guess just a piece. Piece with a message, with a message. We really, I mean, really, like it's just the piece number. I think I should do this. Just the index of the piece that we're asking the peer for. I also need to add documentation to this at some point, but whatever. So, actually, I don't even need to do this. I can just do like piece U32 question mark. Will that work? That can be a U8, by the way, but, well, actually, can it be a U8? Okay, you know what? Wait, I feel like we should just go ahead and be safe and do it like that, a U16, because there's, wait, how do they go to the numbers a U8? Because a U8 is only 256 spots. That's definitely dangerous, but a U16 is going to be 2 power 16, which is, yeah, there's no way that a peer has a bit field that's a U16, or that overflows a U16. But they might have a bit field that is longer than the maximum value of a U8, which is 255. So U16 should be safe. So let's match command. peer command, piece, and piece. Hold on, my cat's here. Let me close the door. I know, I love you too. I know. Okay. Piece dumb. Okay, so now, been waiting for like 3 months to write this code. We can actually start making requests. So, let's do let request equals peer messages, request the index. Ooh, this might get a little bit tricky. Oh damn. Okay, this might get really fucking dicey. I'm gonna be honest, I have no clue how to do this. Here, hold on, let me just put zeros in here so it doesn't yell at me. Okay, so I guess we'll just make that a U32. I thought that would be fine, but wait, let me go back into my diagram. I thought, let me see, request contains the index begin length. Length is usually power of 2. It's like index refers to literal piece index, of course. Index refers to the offset on, begin refers to the offset onto that piece, and length refers to the length of the block that we're requesting. Okay, firstly, is there anything in the peer struct itself that would be interesting here? As IP choked, ID pieces, upload rate, download rate. Because I think there should somewhere, there should be like a thing where the peer tells me how long the pieces should be. But I cannot find. Okay, hold on. Hold on. Okay, I'm back. Sorry about that. No comment, Your Honor. No comment. Okay. So I guess how do we find the the begin stuff? Here I can look here. This is sometimes like super useful. It rejects the piece index offset and then the length, of course. So as in above, due to nearly all clients in the wild, reject requests are not 16 kilobytes. We can assume the field to be 16 kilobytes. So we're gonna just magically assume that it's supposed to be 16 kilobytes. And I'm really hoping that is actually right. The begin, the offset into that piece, that's what I don't know. So I'm a little bit concerned about, if you will. Let me link this. Yeah, this is weird. Because the begin, I don't know what the begin should be. I really have no idea. Let me look at PEP 03. Take a look at piece. Contains the index begin and piece. Yeah, see, this is what I love about the BitTorrent documentation. It doesn't even tell me what the index begin and the piece are. It just expects me to know, I guess. All current implementations use. Let me also quote that. Because that'd be good to know. BEP03. Enclose connections which request an amount greater than that. Yeah, but here's the thing, buddy. I have no clue what what the offset is. Okay, I guess for now we're just gonna assume it is actually 0. For now we are assuming that the offset is 0. This will likely need to be changed in the future, question mark. Cause yeah, I have no clue otherwise. Anyways, then we need to stream dot send request dot wait dot unwrap. We're definitely need to add some error handling to that. What would that actually look like, by the way? Just the whole stream.send thing. I need to look, because I want to make sure there is a timeout on that. So here, look at the definition of this. There should be some sort of timeout somewhere. Hold on. I don't know if there is. TCP stream. Write all timeout, Rust. Let me see if there is. Can you add timeout? I mean, I could do a timeout myself manually, but well, actually, no. Sorry, there's no reason to have a timeout here, but there is a reason to have a timeout here. So, because I mean, like, if we don't send that for some reason, but oh, maybe we should, because like, what if something goes wrong here and we can't send it? So maybe okay, you know what? Maybe we should just time out everything. Time out everything for safety. Timeout Rust timeout in Tokyo time. This is simple to use. It's just it's just kind of weird. Okay, so I think what should be timeout from, I'm guessing that's Tokyo because it says, I'm guessing it's fine, question mark, Tokyo time. Okay, you know what, now I'm wondering if I didn't actually no, it did. Okay, cool. Timeout duration from seconds, and let's just make this a constant. So let's just do constant. Send timeout UA. Let's be like really fancy about this. Is equal to 5. Okay, you're gonna be fine. You're gonna be fine. Oh my god, there we go. Send timeout. Send timeout. The future is as follows. Dot wait. Dot should almost definitely map the error. I have to actually do something with that at some point. Here, let me just. Okay, so this should be like map error. Timed out when sending a message. We'll add more on that in just a second here. Oh, it wants a U64. Okay, well, I can just change that to be a U64. It doesn't really matter. Okay. Why is this a double result? Oh, right, because there's an actual. Isn't there like a timeout and a timeout or something? Like, I'm gonna have to like actually read the docs. Let me see. So should. I feel like I'm like really overthinking this, as I always do, but let me look. Okay, so if we have this, timeout actually like see if there's like a better example. Is this literally? That's funny. I think it's supposed to be like a university or something. Okay. So because this thing, I think there's a. Hold on. Let me look at handle commands. It should be in. Hold on. Here, I can just go here and then GD. Close this. Okay. Because I feel like. Hold on. There, excuse me. There's a timeout usage in here. So this is just. Oh, okay. Yeah. Okay, I know what I'm doing here. Maybe. We're just gonna act like I am. Hope that I'm actually like somewhat right. Okay, so firstly, peer should be self.socketAdder. This should be. Well, actually, I mean, we could. Okay, yeah, no. Let's be smart about that. Let's send result that, and then we also need to handle send result dot. What does inspect do? I keep saying that function. It calls the function with a reference to the contained values of. Okay. That's too much for me to understand. Hope that it's not too important or pertaining to me. Well, actually, hold on. There literally cannot be an issue with this because .send doesn't even return anything. Like if we go to .send, it literally does not return anything. Well, wait. No, it does. Okay. Glad I caught that because I would have done that and looked like a dumbass. Okay. Glad I got that. So, close this, go back to here. Yeah, no, so we do need to map error. Which I think we can just do. Wait, can we just do like. Please? Why not? Wait, async function that returns result or option or another from. That does. That's return. Yeah, result or option. Huh? The async function, does it want to be used here? I'm actually. Oh, wait. This function should return result or option. I guess that is kind of the. Okay, so I guess this is where we get to the point where this doesn't really need to return anything. What it does need to do is communicate that there is an issue back to the beer. So, okay, so what we need to do instead is to just do if send result dot is error. What we should do, I think, is something along the lines of this. We should do 2tx.send. It should be a peer response, but it should be like piece failure or something. Peer. So it should be like piece failure. A piece that. Also, what we should probably do is we should include this. We should do. So we should do like piece num, which is U32, and then error, which is going to be a peer transport error, a piece that was failed to get. That's poor grammar. A piece that failed to the message that is sent when a peer fails to retrieve a piece. So now what we can do peer response, piece failure. We can do piece num is piece num. And again, we have to specify this because might not. Oh, I can do that. Because oh my gosh, words are hard today. I'm sorry. We have to specify that because again, this is asynchronous, so we might there might be like 5 pieces sent before this time's out, right? So okay, so we specify the piece num, and then the error. How do we get the error out of send result dot error? I think we can just do let errors equal send result dot error dot unwrap, and then this should be the peer transport error. And we map the error. There has got to be a better way to do this, I swear to God. Failed to send piece failure message from peer e self dot socket address. I swear to God, there has to be a better way. I swear, there has to be. There just has to be. There's here, because here's the thing, we don't want to fail that immediately. How does Tokyo recommend dealing with this? Because like this has to be a problem that people thought about. Because like, how do you? So I don't just want to unwrap because I don't want to have that implode in my face, right? But I don't want to return something from this function either. So yeah, Tokyo message passing, great, good. I mean, they just unwrap it, to be fair. I actually, okay, you know, okay, I say that, but I guess, I mean, to be fair, if we can't send a message, then something's gone horribly wrong, and we should just implode, I guess. I mean, I think that's fair. I think I think that's a fair way to think about that. Question mark. Let me see. Yeah, no, they keep using just a wait to unwrap. So I guess, yeah. Yeah. Okay. Well, we're just not gonna think about that too hard, I guess. If piece once request message is sent, wait for piece message in response. Okay, so now let's see. Okay, so let actually hold on. We probably like rename this because it should be like request result. Request result. Oh boy. Oh boy. Send request result. What are you mad about? You're probably mad about that, aren't you? Okay, whatever. Let me save real quick. There. Okay, so let piece result equal something very similar here. And we're also just going to kind of copy this over. Do constant. Probably change to like request timeout. Request timeout. Request timeout. I know. You're fine. Let constant piece timeout, which is a U64. We'll just have this equal to 5 for now. Duration from seconds. Piece timeout. Stream dot receive. I literally cannot read it. Okay, that was right. Okay, so receive data is from a peer stream. Dot await dot and I guess we're gonna copy this. So that's quite a bit here. 24. Okay. And then let's see. Once we have that, we'll do piece result dot. I don't want to unwrap that. I want to kind of just want to do the same thing here. Well, actually, no, because now I actually need the result back. So we need to handle this a little bit more properly. So we're going to do something very similar to this, but not the exact same thing. So if piece result is error, then that's the error that we got. You're going to be fine, Vim. Shut up. But if it isn't, I think we can still unwrap that, can't we? Yeah. Let piece equal piece result dot unwrap. That should be a piece. Oh, god damn it. Okay, and there's no way we can clone that, I bet. Yeah, no. Yeah, I just kind of realized that. I was like, oops, yep. Yeah, no, we can't do anything like that. Do this method call if each result is error. How can we deal with that? How do we properly deal with that? Is the better question. Because if we piece result, I know there's like you can just like flip it around or something, but this ring actually get skipped. Does not implement the copy trait. That kind of makes sense because it shouldn't have to implement the copy trait. Okay, so how do I deal with this? Come on, brain, do something fun. I guess what we can do is we can do just a match. So basically just do match piece result, and then do, if it's an error, well here, let's do okay, piece do something, error E, and then kind of yoink this a little bit. Yeah, and then we're not gonna need this. I don't think. Oh, why are you moved? No. Oh, actually, no. That should be fine, because now we have our error E. There we go. And E should keyword should be a, well, actually, yeah, no, it is, because I mean, like if I put like a 3 in here, that would be mad at me because it wants a pure transport error, so that is a pure transport error. Okay, so then the piece, now we have the piece, so we need to send the piece back, I think. So we need to do 2tx dot send pure response. Pure response should just be piece, and because I think we're just gonna send a pure message that's like literally just the piece, entire piece back. But hold on, we also need to make sure that this is actually a piece message, because if it isn't, then that's an issue. So let's see. Okay. I think previously I would have just done a match statement here, but I think that it's probably easier to just do an if let. But I'm not sure, because I think we can just do, here, let me look at my repo and see if there's anything else. Let's see, because I don't really want to return an error. Cause yeah, well, I mean, I guess I can do that. There's no reason not to do that. Yeah, okay, so I guess we can just do if let sum piece is equal to, how do we want to do this? I have to look at my repo again. If let peer is going to take you. Okay, so I think. So if let peer messages piece. Oh, okay, that complicates things. Well, no. I mean, kind of, but not really. Peer messages. I should look at docs for this, man. Look at this. Okay, the piece should be the index offset in the block. It should be very similar to the request. Oh, this is weird. Okay, well, wait, hold on. I shouldn't need, well, this is where it's weird. I'm telling you. I might just go back to using a match statement, honestly. Let me look at if let rest. If let destructures number sum I. If let destructures number into sum I, value the block. Oh, we can literally just do this. I think piece is equal to piece and do something. Will that work? No, it won't be. Oh, man. Okay, well, maybe I can just do this. Okay, that's going to be fine. We just delete that for now. Okay, so if let peer messages piece, and then, so if that is the case, then tx dot to 2tx dot send peer response piece. Oh, because there's nothing in there right now. Message peer messages. It should just be. Actually, no, it should really just be piece. Oh no, sorry. Peer messages like so. And then delete that. Piece. Peer. No, it should just be piece. Okay. Happy with that. Okay, I think that works. Kind of, maybe. Then we're also gonna have to do this. Failed to send piece message from peer. Okay, honestly, I think that's like actually kind of what I should be doing. It has been tracing real quick, but I just forgot like how many lines of code is that? Like 50 lines of code. And I feel pretty confident that I did not the wrong thing, which is frankly, it means that we're going in the right direction, Okay, so we don't need to trace everything because there should be some traces in here. There should. I say that. Oh wait, no. I'm just gonna here and see. Send. Okay, maybe there's not. I'm just gonna go ahead and trace it. It's gonna be safer. Trace making request to peer self.socket header. Okay, everything else is gonna follow a very similar format to this. So successfully made request to okay, and then if there's an error, we do that. Trace waiting for piece message in response to request from peer self.socket adder. Oh, right, I can do that. I forgot that. Okay, anyways. So I guess... Okay, I think it seems... Okay, I think it seems reasonable. Okay, okay. Okay, okay, and then we just do, this is, got message from peer, whatever it is, and then this should be an error. So this should be like, I don't know, something went wrong when retrieving piece from peer. And then we have the actual error here. I know I can do the error in the colons, but I like doing it out there. It feels better. Okay. I think that looks reasonable. It's a lot of match statements, but I think it's alright. And then here, also I should just log this. Message from peer was not oh my gosh. Message from peer was not a piece message. Message from peer. Let me figure out what peer did. Oh, there we go. Fuck. Back up. Message from peer. Peer self.socket adder was not a piece message. But we probably should also tell. Okay, because here's the thing. Because I want to tell the peer, or because I want to tell the engine that we failed, but if we just have a timeout on the RX and what is here? It should be fine. If we just don't bother sending that. Yeah. Okay. There's not a piece message. Okay, so I vote that we don't send anything just because. Yeah, I feel like that just complicates things. Yeah, and there's no reason to say like, oh, this didn't work because there was the wrong message because something else could be going on potentially. So let's just stop there. Okay, I do need to write test for this at some point as well. So commit minus feet. Oh, hold on. Git commit minus feet added request / piece message loop. Git push. Okay, 2 commits down. Nice. I'm pretty content with that. I'll enter some. Okay. Okay, so since there's nobody watching right now, I'm gonna go ahead and call it right here because I want to get lunch. But I'm probably gonna be back later. Maybe. We'll see. Peace.